I feel like when we talk about it that you guys have a good understanding of it, and then when it's time to take a quiz, everybody really struggles. So everybody knows that the coordinate grid is the same all over the world, right? I could go to Zimbabwe and say, hey, what is this measurement in degrees right here? And what would they say?
180.
This is 0 or 360, right? If we go all the way around, it's also 360 degrees. Everybody's okay with that?
Yeah.
Is anybody confused by that? Don't not listen to me today and then have questions on this on Monday or Tuesday. Everybody's okay with if I go to Switzerland and I say, okay, well, what measurement is this? Straight up here, what is this?
90.
It is always 90 degrees. What is this one over here?
180.
180, and what is down here?
270.
Okay, so we don't ever use, when we're calculating things, we don't like to use large numbers. It's hard. So we use small numbers, specifically small positive numbers. But sometimes the problem that they give me involves something that started over here, and it goes all the way around 312 degrees and ends up over here. But 312 is too large for me to calculate with. I don't want to program my calculator to figure that out. So instead, I use what is called a reference angle. And a reference angle goes from the terminal side, where you stopped, back to the x-axis always. So this reference angle would be how much?
48.
48 degrees. Because 312 plus 48 would get me all the way back around starting at 0. So there is a 48-degree reference angle in every quadrant. This one, they always come from the x-axis. So if I'm going to go up from the x-axis, 48 degrees, there will be a reference angle right here. But that isn't in standard position. That's just the angle I'm referring to make it easy. This is in standard position. So this angle in purple would be how much? 132. Because 132 plus 48 makes 180. There's also a 48-degree reference angle coming down this way. But 48 degrees is only the reference I'm using to make it easy to calculate. The actual angle is this obtuse angle that starts at 0 and comes all the way around. How much is that red angle? Because I add 48 to 180.
22, right?
48 and 180? 8, 9, 10, 11, 12.
Oh, yeah.
Is everybody, so, and the reference angle, there's a reference angle that goes right here up from 180 to 48. Guess what? It is 48. Is everyone okay? Is there anything I can do to explain that better? Can I ask you another question that might help you? Like, can I ask you one and y'all look at it and see if you can figure it out? Would that help? Because really, we did this rotation angles. We started this last week, and it was on the first day of this, and we're still struggling with it, and it really shouldn't be that complicated. So I would like to know what can I do to help you? Do you want me to put one up and see if you can figure it out? Like what was on the quiz? Let's see. I'm going to give you one and see if you can tell me.
Is your rotation angle on this assignment the same thing?
Yeah.
Does that mean the same thing?
Mm-hmm.
Okay.
Oh my goodness. Something's so rude. Okay, so take a second, and I want you to find all of the quadrants angles that has a reference angle that is the same as 117. One for quadrant 1, one for quadrant 2. All right, now first off, where is a 117-degree angle?
Quadrant two.
So that is the one that's in quadrant 2. Now, what is the reference angle for 117 degrees? 63. Where would 63 be? Quadrant 1. All right, so now I need a 63-degree angle that lies in quadrant 3. Because 180 plus 63 degrees gives me 243. Now I need one in quadrant 4 that's a 63-degree angle. 297. Because you take 360 and you subtract the 63.
So if you find one and two, then just add 180 both of them?
Yeah, you can do it that way, yes. Is everybody okay? Are we sure? So when I give you reference angles on the quiz on Tuesday, everybody's going to go, okay, this is easy, I can do this, yes? All right, now, on day for yesterday, because I wasn't here yesterday, we did this same science but different science, where we talked all about the reference angles. Over here, you have this little chart. You're going to need that. You are going to need to memorize it, but today you can use this little chart. It's going to help you with the assignment, and by the time you use it, as much as we're going to use it, you'll kind of have it memorized, I think, at least if you're thinking while you're doing things and not just kind of absent-mindedly doing things. But remember what we realized when we were doing this page is the calculator is going to give me one answer because it doesn't have any idea what your actual triangle is or where you're actually doing the problem. So it gives you one answer and it may not be the answer you need. So this little chart tells you how you can find the other potential answers. So on this page, Situation Solver, I am looking for, on problems 1 through 6, I'm actually going to find 2 solutions that lie in the interval of negative 90 to positive 270. And so I'm solving for theta. Now there's a difference. And on one of the quizzes, it asked you, like, for example, it said, what is the exact answer of tangent theta? Tangent theta is a problem that's not completed yet. So you're processed through. If the problem's not over, you haven't solved the problem until theta is by itself. So on that quiz, when it says tangent theta, it wants just the fraction. You're not completing the problem until it says, you don't use your calculator until it says get theta by itself. In this case, I am actually looking for solutions. I need theta by itself. I need cosine gone. How do I get rid of cosine?
Inverse cosine.
Inverse cosine. So I'm going to arc cosine this, or inverse cosine. Those are 2 names for the same thing. Put that in my calculator. Make sure your calculator is in degrees, because who knows who has 2 plus 7, 1, 2 did. All right, so I put 0.34, inverse cosine 0.342, and it gives me 70 degrees. So that is definitely in the interval between negative 90 and 270.
So then could you add or subtract?
So then I look at what it says I can do with things that I get from cosine, and it says I can add or subtract 360. But if I add 360 to that, that's too big.
So you subtract it.
I can subtract 360 from that, but that's too small. But the other thing you can do for cosine is the easiest one. You can also just make it negative. Whatever the calculator gives you for cosine, you can also just make it negative. And in this case, that is right in my interval, -7. That only works for cosine, that you can just make it negative, but it's a nice one. It makes it easy. So tangent, sine, you're going to do all these the same. But real quick, let's jump down to number 5 because it's cosecant and you don't have cosecant on your calculator. So I can't just inverse cosecant it because I don't have an inverse cosecant button. But cosecant is buddies. What is cosecant buddies with? Sine. And what is their relationship?
Opposites.
Not opposites, but
Just flip it, don't you?
you flip it. It's reciprocal. They have a reciprocal relationship. So I could flip 11 over 7 over and make it 7 over 11. And now it's no longer cosecant. It's now sine. And I do have an inverse sine button. So I'm going to make this inverse of sine.
Do we have any of the
No, these calculators don't.
Can you tell me the best?
The Inspires, the newer TIs, they do these stuff. Inverse, not tangent. So inverse sine of 7/11. All right, that gives me 39.5. Is 39.5 in your interval?
Yes.
All right, so that's one of them. Now I need another one. And so I can't just make sine negative. That doesn't work. But if I look at my little rules for what I can do with sine, it tells me this is, so the first thing is that's what the calculator gives you. Or I can do 180 minus what the calculator gives you. So if I do that, 180 minus this, 140.5, and that's in my interval, so that one won't work. Is everybody following?
Yes.
All right, cotangent, what is cotangent buddies with?
Tangent.
And when I flip it over,
It'll be
it'll be negative 1/4, good. Because there's an imaginary 1 in there. Okay, so that's easy. Now when you starting on problem number 7, which 7 and 8, you can use whatever you want. You don't have to use sine, cosine, or whatever, whichever one you want to use is fine. On 7 through the rest, you're not looking for 2, you're only looking for 1. So 7, 8, 9, you're looking for the one that is in the picture. So look at 7. Look at the one that's drawn in the picture, this one. What can you tell me about the angle that's going to be my final answer?
Negative.
It should be negative and fairly large. It's way over 180. So that's the one you're looking for. So if that's not what your calculator gives you, you have to use your little chart and figure out how you find that. And be careful down here on these intervals, because these intervals are being changed. So the first two are 0 to 180, but then all of a sudden it goes from negative 180 to 0, and then this one's 180 to 360. So just make sure you're checking your interval every time. And then these down here, where it tells what quadrant it terminates in, it doesn't matter if it's positive or negative, which is as long as it terminates in the quadrant that it says. So go. If you need my help, please ask.